Today, I'll show you how to connect your Rust application with the Postgres database using Docker Compose. We'll continue to build in our movies database example that we have been doing since lesson 2. In order to follow along, you'll need to go to our Git repository and clone the code. Alright, today I want to use a slightly different approach. I'll start by demoing the app and then I'll show you how to build it. So let's go ahead and start the application. First thing you have to do after you clone the code is go to lesson 4 and then run docker compose up. The beautiful thing is that that will start both our Rust application and also the database. Now let's head to the browser and refresh. So great. This is very similar to what we did on lesson 2, but remember that the difference is that now we are using Docker Compose and Postgresql to store the data. Let's go ahead and add a movie to the list. To do that, I already had my commands prepared here. Let me just go ahead and change the title. So I want to insert a movie called Aliens. So let's see what happens. So as you can see, the server responded with the movie, right? So we posted Aliens and it replied with the same movie that we posted. That's due to the API that we designed on lesson 2, so no changes there. Now if I go to the browser and I refresh, I see that the new movie Aliens is inserted. So that's great. Now let's go ahead and delete a movie. So I already had the command kind of prepared here. So yeah, it should be gone now. Yeah, it's gone. So that's, we tested adding a movie, deleting a movie. Now let's go ahead and test searching for a movie. So there you go. So if we do movies / and then the name of the movie, it will return the movie or a null if it doesn't find it. Great. Very straightforward. We are not changing the API. Alright, so now let's take a look at how the application works. The best place to start, in my opinion, is to look at the Docker Compose file. The Docker Compose file defines all the applications and middleware systems that interact together in your computer. You can think of them as separate computers. So the first service is called library. This is actually a Rust application. Then we have our middleware. We have the Postgresql database and then dbmate. dbmate is used to perform the database migrations that we'll discuss in a moment here. And then you see this networks element. So networks in this case is used to define how containers communicate amongst them and also how Docker communicates with the local host, with my computer. So you might be asking, why using a bridge network? Well, if you use a bridge network, then the DNS resolution amongst all the containers will be automatic. Else, you'll have to address them using IPs. So let's look at library. So if you guys remember lesson 3, we discussed how Cargo Watch works in detail and also how the Docker file is defined. So if you haven't watched that, please go check it out. But it's clear that in this case we are defining which Docker file image to use. And then this is very important. We are defining that there's a relationship between our Rust application and PostgreSQL. So you can think of it as like connecting the Rust application with your database from a network standpoint. Then here we define the URL of our database. And then the port that is exposed. That's how we're able to hit the container on port 8000. Then moving on to the middleware. All right, so let's move on to the middleware. Here we can see that we are using this particular version of Postgres 12, and then we are setting the default password for the Postgres user. We also define the network that this service is attached to, so library network, and then the port that is used to expose the Postgres. So this is the default Postgres port. And the other piece of middleware that we are using is dbmate. dbmate is used to run the migrations. I provided a dbmate Docker file for you to use. And then upon starting, Docker is going to call this create db script. And all it does is it waits for the Postgres database to start, and then it runs dbmate up. dbmate up is used to trigger migrating the database. And then after, we just print done. You might ask yourself, okay, where are these database migrations? Well, they are in the db folder. And these migrations are executed in the order of these timestamps. And the first file creates a table called movies that contains 2 columns. And the second file contains some sample data so that you can get started. Now let's take a look at the Rust code, which is why you guys are here for. Okay, so I'll try to explain you this code the same way that I'll explain this to a coworker at the office at Security Union. So all Rust applications start with a main method. Then you can see that all it's doing is calling the rocket method and then just launching it. So let's look at the rocket method. Here on line 48 is where we create the database connections. Then we pass that connection pool to Rocket on line 53. So why am I creating this proxy object here? The reason is that moving forward, we'll start adding more elements that we want to pass here, such as Redis or RabbitMQ and some other things. So what I mean is maybe tomorrow we want to pass Redis and then RabbitMQ, but we'll add it here. So you can see it as a pattern that Rocket uses to manage state. You can see on line 53 that we pass the managed state to Rocket. And then the beautiful thing is that on each handler, the state will be injected. This is extremely clean, and it creates a nice pattern for passing state. Now, what are we doing here? This is a way to get a database connection from the connection pool. And if this fails, because we are calling on wrap, this will cause the application to crash, actually. Like if the database goes down, I rather like the whole application crashing than having like a zombie application, because when we discuss service orchestration and how to run this in production, we'll see that usually if your application crashes, then it will just restart right away. So I consider that it's better just to let the thing crash and restart real quick than to have a zombie application. Then after getting the database connection, it's going to call the model. In this case, we are looking at the getMovies method. So it's going to call the model and it's going to fetch all the movies, right? So let's look at how that's implemented. That's right here. So let's look at read movies. So first we prepare our SQL statement. So this is straight up SQL, nothing fancy about this. Then we execute the SQL statement. And then here what we are doing is transforming the results from SQL results to movie objects. Read movies, you can see the method signature. It says that it returns a vector of movies, or an error, depending on what happens here. So what will happen if for some reason this query fails? Well, then the code will stop on line 38. It won't proceed to map over the rows or anything like that. It will just return an error to the color method. So this should be a little bit similar. We'll discuss why are we doing this flatten method call here. But first I want to show you how we read one movie. So this implies that we're going to add a parameter to our query, right? The title of the movie. So you can see that the SQL statement is similar, but we are adding, oh, actually this is, all right, I apologize. There you go. So the SQL statement is similar, but we are adding a where condition. Where title equals to $1. And then on line 57, we actually pass a vector with all the parameters. So in this case, we pass the title of the movie. Then why are we using this fold method as opposed to map, right? You could ask that. Well, we know that in this case, we will either get one movie back or no movies at all. So by using fold, we are able to transform many rows into a single row. And don't worry about it. I know that I'm not going into too much detail on how each of these methods work, but basically I want us to get this system off the ground, and then I'll show you how to go back and actually learn very interesting details about how Rust works. But for all practical purposes, you should be able to run this system and understand what it's doing and like get started with Rust. I encourage you to like modify the code slightly, and obviously this will be all open source so that you can use it for your own applications. But one thing I want to convey at this time is that you do not need to understand a programming language like in detail to get something running. In my opinion. I know that a lot of people might be yelling at me right now, but you know, that's my method of learning and the way I want you to at least try to learn Rust in like what I would call like circles, where on each iteration we'll go deeper and deeper. But by the end of this section, you'll have a Rust application that consults a database, interacts with the database, and it runs using Docker, which is pretty amazing. So anyways, that's how read movie works. Now, moving on to the next method, we have how to post a movie, right? And this was discussed in lesson 2, but I want you to really appreciate how Rocket is deserializing the inbound movie into an object. That's pretty amazing, right? We didn't have to write any manual parsers, which is pretty fantastic in my opinion. Then all it does is just calls the insert movie method, and if it's successful, then it returns the movie back to the UI or to the caller, else it returns none. And there are more functional there's a more functional way of doing this, right? Here we are doing pattern matching. There's a slightly more functional way of doing this. Hey guys, that match was really bothering me, so I decided to look at it more closely and see if I could change it for something slightly more elegant. So let me know what you think about this. So when we insert the movie, we get back a result. That result either has the rows that were fetched from the database, or it has an error. So in this case, I'm taking that result, then converting it to an optional by using the OK method of result. And then I'm saying, well, go ahead and transform those rows that you got back from the database into the inbound movie. And then it's possible that inserting the movie failed, in which case OK will be like once we transform the result to an optional using OK, this will return none. So we'll return JSON of none to the caller. In this case, JSON of non-optional is null, a null value. So with that, we finish this method. I consider that this is more elegant than a match statement. Let me know what you think in the comments. And then this is going to be kind of the same deal, right? So, this is ugly. So let's go ahead and do the same. So, so we say that the result should be a boolean, right? So here we're saying, okay, so that's transforming our result into a boolean. And then we'll go ahead and do the same thing that we did before, map it. Just map. As a matter of fact, this might be even easier. We don't need any of this because there's a method that says is okay, right? We don't need any of this. JSON of result. And we are done, I believe. If this line looks a little bit too long for you, then we can break it into 2 lines. Basically, you want things to be very nice and readable. Course title. Oh yeah, of course. There you go. So hopefully this is slightly better to read. And you know what? Maybe we can put it in the previous line. There you go. Beautiful. Much better than a nasty match statement. Once again, why are we transforming the result to an optional? Because in this particular implementation of the API, we don't care about what the error is. On a follow-up video, I'll show you how to transform the database error into a JSON so that you can send it to the UI for diagnostics. Well, let's see how delete works. So if we look at the model, we go, the database model, then we go to delete. We'll see that the format is the same. We prepare our delete statement, which is plain SQL, and then we just execute the query and pass, replace this $1 with the actual parameter, which is the title of the movie that you want to delete. And that's it. Easy peasy. Okay, so here's how we actually connect to the database. If you look at get pool, you'll see that the first thing that we do is read the PG URL environment variable, which contains the complete URL to the Postgres database. That includes the host, the password, the user, obviously database, and so on. That gets us a manager. Then we also pass the Postgres pool size as using an environment variable. So you can think of the pool size as the number of connections that are used by your application. We use environment variables because we want to be able to configure that using, in this case, Docker Compose, but in the future we'll see how to use Kubernetes to do that too. Then the third line will actually we'll build the database pool, connection pool, and return the pool to the caller. And that's it, just 3 lines of code, which is pretty amazing, right? All right, friends, so that's pretty much it. Hopefully now you have a great template using Rust, PostgreSQL, and Docker Compose. And, you know, one very cool aspect that I covered is migrations. I am used to tutorials where they never cover that, or there's like a separate tutorial where they only cover that piece, but I've never seen like everything put together. Let me know what you think. My goal here is to create very practical tutorials for you guys so that you can get started real fast. See you guys in the next video. Ciao!